In this video, we're going to learn how to use side length to prove triangles are congruent. The side-side-side congruence postulate states that if three sides of one triangle are congruent to the corresponding three sides in the second triangle, then the two triangles are congruent. So the example here shows that these three sides are congruent to the three sides on a separate triangle, and because of that, these two triangles in the diagram to the right, triangle ABC is congruent to triangle RST. This is a fairly easy concept to understand, and let's see how we can use it. Use the side-side-side congruence postulate to write a proof. I'm given that Fj and Jh are congruent, and G is the midpoint, and because of that, I know that Fg and Gh is congruent. So with that information, I already have two sides of the two triangles are congruent to their corresponding sides. So let's write that out. Here is my statement, and here is my reason. My reasons are here. Okay, so if I know that Fj is congruent to Hj, and that's given, I also know that Fg is congruent to Gh, and that's definition of midpoint. And I also know that JG is congruent to JG, and that's reflective property. And so now I have three sides are all congruent. I can draw the conclusion that the first triangle, FGJ, is congruent to the second triangle, HGJ. And that's my side-side-side congruence postulate. Okay? Here's some practices. Let's see, the first one. The two triangles are congruent. We have to decide if that's true or not. In this case, it's true because I have JL obviously is congruent to LM because they're both are 9, and JK is congruent to KM because they're both 8, and LK is congruent to LK, and that's reflective property, and therefore my JKL is congruent to MKL, to triangle congruent. Okay, now let's look at the second one. Is it true that these two triangles are congruent? I see that there's one pair, there's a second pair. But the third pair is not congruent. There's no indication. Therefore, the answer to this one is that this is false because RS is not congruent to TV. Here's an example that's a little bit more involved. Determine if the triangle on top, PQR, is congruent to the other two triangles at the bottom. So let's look at them one on one. So PQR is 1, and let's see if that and RST is the second one. So let's look at these two first. Some coordinates are given. So this point is 3, this point on the y-axis is 1. So we can basically, if we start counting, we can find out all the coordinates of the vertices. And So you can do that. If you find the coordinates, you can use distance formula to calculate the distances and see if they're congruent. That's one way of doing it. Another way of doing it is if you notice that PQ is, if we count that PQ is 3 and QR is 5, and if I use Pythagorean theorem, I can calculate that my what's that, PR would be square root of 3 squared plus 5 squared. So that's 25 plus 9. That will give me 34. So square root of 34. Let me perfect my chicken scratch a little so that we can actually read it. There we go. So I've got 3 sides, the length of 3 sides here. And then let's look at my second triangle. Let me change the color to red, RST. So my RS, the length of RS is 3, and the length of RT is 5. And of course, if I use Pythagorean theorem, and again, the reason I can use Pythagorean theorem is because these are right angles. And of course, my ST, oops, where's my eraser? Here it is. Let me erase this. No, I can't. Oh well. So my ST should equal 34 because 3 squared plus 5 squared is 34, and we have to square root that. So for my second triangle, all 3 sides are congruent to their corresponding sides in the first triangle. We can draw the conclusion that triangle PQR is congruent to triangle RST. Okay? You can do the same exercises between PQR and VWR, the third triangle, and you will find out that these two are not congruent because some of the sides are not of the same length. Here is another example, DFG. Again, all 3 coordinates are given. And L, M, N, the 3 sets of coordinates are given for the vertices as well. And you can use the exact same approach, or even better, try to use the distance formula and calculate the distances of each line. So if you recall, the distance formula is x2 minus x1 squared plus y2 minus y1 squared, and take a square root of the whole thing. So again, either you use Pythagorean theorem or you use the distance formula. Personally, I prefer the Pythagorean theorem a little more, only because I don't need to deal with 2 numbers in the coordinates. But in this example, the distance formula works a little better. Okay. So that's it. If you have any questions, bring it back to school. We will see you soon. Bye, guys.